Today we're going to discuss proximity sensors, but first of all we're going to look at the sensing fields of both shielded and unshielded. A shielded sensor has threads all the way to the top, and so consequently the sensing field is directly in front of the head of the sensor. Unlike the unshielded, which you'll notice that there are no threads at this end, has that bubble effect at the top of the field, and therefore the sensing field is much larger than that of the shielded. Capacitive proximity sensors have a sensing field that actually bellows out, as you can see here, because it is unshielded, and it also is putting out a large area of magnetic field. So therefore it will pick up and will sense in this area, as well, directly in center. Today we're going to discuss the first line of electronic sensors, proximity sensors. These sensors are highly popular in industry as well as in city traffic applications, alarm systems, and safety systems. There are basically two types, capacitive and inductive. We're going to be looking at the capacitive, which this is here right now, and I think you'll know as I explain this that you've come in contact with this and not even known it. The capacitive sensor, you can see that is looking for a ground, and me, a human, is a ground, so as I get close to it, it will activate. I don't even have to touch it. Now, it will not activate on something that will not conduct a ground, such as PVC. Will not make anything, but if I take something that would promote a ground, such as metal, it will pick it up. Now, this sensor is often found behind elevator door buttons. You'll see some of these that are not mechanical. They don't move, but they just light up and you touch them. So therefore, this material will not conduct the ground. But as I hold the material behind the sensor and then approach it, and I'm the ground, I would call for the elevator. So this will look through things like plastic and PVC, but when a ground enters from the other side, once again, it will activate. So it's a very reliable sensor, and it's used in many applications. I've attached a capacitive sensor to a small table, and all that's indicating here is the top. This is often used for security, both in museums and jewelry stores and such. Example, in a museum, we may have a very expensive portrait of somebody on display. When the portrait would be possibly moved unintentionally, it would set off an alarm. So this is allowing us to use this for safety purposes so that this will not be removed. Another way of using this is a valuable coin. And if the coin was on display and someone decided to take a look at it and pick it up, it would set the alarm off. This is the first line of sensors that's finally using an electronic control system. In this case, we're using what we call a digital logic controller. This can also be attached to a PLC or a computer system. We also can use a capacitive sensor in water reservoirs or in medical terms. We can use this in the event that and the bottling industry for filling bottles. Give you an example, water will ground a sensor. So consequently, here we have the sensor connected, and it's looking for a certain amount of water. So as I add water to this, and it reaches the sensor, it'll set off an alarm. Which is telling the operator that that bottle is now full. Another application for a capacitive proximity sensor is used in the medical field to monitor an IV drip. So as we simulate a drip going past it, it will count each drop that passes by the sensor, therefore giving the nurses a digital readout of how fast the medicine is being applied.